Hi all, so this is the subway problem that we worked on in class and that we went over. I'm going to go over it one more time just in case you were still a little bit confused from class. So the problem says, for every morning Richard takes the Red Line T train to work. His walk to the train station takes 3 minutes, and we're going to assume that the train departs from LA station every 10 minutes. So for example, 9:08, 9:18, 9:28. And if it all goes well, the ride to work takes 7 minutes. And we want to create a table and a graph. We want to create a graph that predicts the time Richard arrives at work, depending on the time he leaves home. So our x is going to be what time he leaves home, and then our y-axis is going to represent what time he arrives at work. And so for purposes of simplifying purposes, let's just assume that we have 9:08, 9:18, and 9:28. Let's use those as times of when the train would leave. And since we don't know in this particular situation what time this train starts running and what time the train stops running, we're just going to, you could technically start at any time. So you might want to start your x-axis at 8 o'clock, 7 o'clock. It's entirely up to you, right? So I'm just going to use the 9:08. So assuming that the train leaves at 9:08, the first thing you can think about is, all right, let's make a table. And in order for him to make the 9:08 train, what time would he have to leave by the latest? And we could say, all right, 9:05. If he leaves at 9:05, he'll make the 9:08 train exactly on time. He'll take the train, it takes 7 minutes to get to work, and he'll get to work at 9:15. But if he leaves at 9:06, so I'm going to start my T table with x there. If he leaves at 9:06, he gets to the train station at 9:09, and he's gonna miss that first 9:08 train. So he's gonna have to wait until the next train, 9:18, and then take 7 minutes. So now he'll get to work at 9:25. Okay, and if he leaves at 9:07, again, he'll have to take the 9:18 train, and he'll get to work at 9:25. If he leaves at 9:08, he'll still have to take the 9:18 train and get to work at 9:25. And so you can see that this pattern continues. And in order for him to make the 9:18 train, he can leave his house at 9:06, 9:07, 9:08, all the way up to 9:15. The latest that he can leave his house is 9:15 if he wants to make that 9:18 train. So he leaves his house at 9:15, and he'll get there at exactly 9:18. He'll take that train, and then he'll arrive to work at exactly 9:25. Okay, but then if he leaves his house at 9:16, he's gonna miss that 9:18 train. He's gonna have to wait for the 9:28 train. And taking 7 minutes to get to work, 9:28 plus 7 more minutes, now he'll get to work at 9:35. Same thing if he leaves at 9:17, he'll get to work at 9:35. Okay, so in order to make that 9:28 train, he can leave his house at 9:16, 9:17, 9:18, etc. all the way up to 9:25 is the latest he can leave if he wants to make the 9:28 train. And he'll still get to work at 9:35. So you see these intervals here, and we can start graphing them. Okay, so I'm going to start at 9:06. So at 9:05, I'm going to draw an open circle. At 9:06, he'll get to work. If he leaves at 9:06, he'll get to work at 9:25. And he will continue to get to work at 9:25 all the way up to if he leaves at 9:15. But then once he leaves at 9:16, then he will get to work at 8:35. So I'm going to draw an open circle here. And these are the times in which he can leave in order to get to work at 9:35. And then if we continue, And look at the next interval. If he leaves at 9:26, he's going to miss that 9:28 train. So he'll have to wait for the next one, which is at 9:38, which means he will get to work at 9:45. And he will continue to get to work at 9:45 if he leaves at 9:26, 9:27, 9:28, all the way until 9:35. That is the latest in which he can leave in order to make it to work at 9:45. If he leaves after 9:35, then he'll again have to wait for the next train, and you see the pattern of what's going to happen. He will get to work. If he leaves at 9:36, he'll get to work at 9:55. And the latest that he can leave in order to make it to work at 9:55 is at 9:45. Okay, so then this pattern will continue regardless of what time you start, 8 o'clock, 7 o'clock, etc. And you can see this as a step function.